2019, paper 1. Question 1. Which quantity does not have a unit? For resistance, the unit is ohms, volume, meter cube, wavelength, meter. Refractive index, N, is given by C over V. C is meter per second. V is also meter per second. So it has no units. Question 2. The label arrows in the diagram represents the direction and sizes of the forces acting on the stationary point mass. So in which direction does the point mass accelerate? So there's a force 3 newtons downwards and there's a force 6 newtons upwards. So it will cancel off, resulting in just a 3 newtons upwards. The one on the left, from the right to left, is also 3 newtons. So you can see that the resultant force is at the angle B. Question 3. Which row shows whether mass is scalar or vector, speed is a scalar or vector? So we know that mass is a scalar, speed is also a scalar. The vector is actually weight, because force has direction. The vector for speed is actually velocity. Question 4 not tested. Question 5. The velocity time graph for a car is shown. What is the acceleration of the car at the 30 second mark here? So as we know, the gradient of a VT graph gives you the acceleration. So when acceleration is 30 centimeter mark here, the gradient here, gradient is equals to 0. So acceleration is 0 meter per second per second. What other thing we can get from the VT graph? The area, okay, under the VT graph gives you displacement. Next, question 6. A heavy object is dropped from an aeroplane. The velocity of the object is measured at 2 points before it hits the ground. The velocity is found to be the same. What is the explanation? A says that all object falls at constant velocity. Wrong. It's constant acceleration. We know acceleration of free fall is g equals to 10 meter per second per second. The force on an object due to air resistance is equal to the acceleration of free fall. Which is not equal to the acceleration, equals to the weight. Okay. Option D, the force on the object is due to the air resistance is being larger than the weight. That's wrong also. It's actually equals to the weight. So it's said to be at terminal velocity. Okay, so how does terminal velocity look like? If this is a free body diagram, it's the weight, the air resistance is equals to the weight. So you look at this. No resultant force. Question 7. What is the order of magnitude of the diameter of the Earth and the diameter of an atom? So as you know, diameter of Earth, 12,000 km, which equals to 1.2 times 10 to the power of 6 meters. Diameter of an atom is about 0.1 times 10 to the power of minus 9. 0.1 nanometer. Question 8. A car has a mass of 800 kg, so M. The car engine exerts a driving force of 2.5 k Newton. This causes the car to accelerate at 2 meters per second per second, A. So what is the resistive force acting on the car? Question mark. So we know the formula, F net equals to MA. And in this case, F net is equals to the force minus away the resistive force. The driving force minus away the resistive force. So we have 800 acceleration 2.0 equals to driving force 2500 minus resistive force. Next, question 9. Which statement concerning the mass of an object, of a body, is not correct? Okay, the body experiences a force in a gravitational field because of its mass. That's correct. W equals to mg. The mass is a measure of the amount of matter in the body. Correct. Option C, the mass changes when the strength of the gravitational field changes. Wrong. It's the weight. Given formula, W equals to mg. Mass resists the change in state of rest or motion of a body. That's correct. Newton's first law. Law of inertia. Next, question 10. A brick of mass rests on one of its flat surface on the ground. Gravitational field strength G is given. What is the minimum pressure that it can exert? So for minimum pressure, you want the largest area. The formula is given by P equals to F over A. And the force here comes from the weight of the brick. The formula for weight, W equals to mg over area. And use the largest area. So this is probably the largest area A. Question 11. Two vessels are joined together with a tube and filled with water. Both vessels are open at the top. What does the water pressure at point R compare to the water pressure at point P and Q? So we know the formula for this is P equals to H rho G. How to get the pressure at R? We take the height, we give it H2. For P, this is H1. We realize that H2 is greater than H1. That's why the pressure at point R is greater than the pressure at point P. Because the height of the water column is larger at R. For Q and R is the same amount of water above it, so it's at the same pressure. Question 12. A uniform tube is sealed at one end and is held vertically with a closed end at the top. It contains a thread of mercury which traps a column of air. The other end of the tube is open to the atmosphere. Then they give you the pressure of the mercury height to be this 0.18 and the atmospheric pressure to be 1.0. So what's the pressure of the trapped air? So you can actually use here at this same point. This is the pressure ATM, atmosphere. This one is pressure of mercury plus the pressure of trapped air. So we can actually form the equation pressure of mercury plus pressure of trapped air equals the pressure of ATM, atmosphere. 0.18 times 10 to the power of 5 plus pressure of air, which is what we're going to find, equals to 1.0 times 10 to the power of 5. Next, question 13. Okay, electric cars use electric motors instead of combustion engines. The electric motor can be used as a generator to charge the car's battery. What is the energy conversion involved in this process? So actually this is the part where it's called regen braking. Okay, so it actually converts the kinetic energy of the car as it's slowing down into electrical energy and be stored as chemical potential energy in the batteries. Okay, question 14. An object is initially at rest. The object is dropped from a height of 50 meters, so height h. The air resistance can be ignored. So assume that the potential energy of the object is 0 when it's on the ground. What is the ratio of the kinetic energy to the potential energy? GPE at a height of 10 meters from the ground. So as we know, GPE loss equals to Ke gain as it falls through the air. It goes to actually mgh. So since it fought 10 meters, so Ke gain at 10 meters is equals to mgh. mg 40 meters. So at the height of 10 meters, the object will have fallen 40 meters. Okay. So Ke at 10 meters ratio to the GPE at 10 meters. mg 40 ratio mg 10. Resolve it. 4 to 1. Question 15. A lorry is traveling at a steady speed along a highway. The forward force is F. The power produced is P. How far does the lorry travel? Question mark. In a time 1 minute. So we convert 1 minute into 60 seconds. With the first formula, P equals to work done over time. Second formula, work done is equals to force times displacement in the direction of the force. Put them together, P equals to F times S over T. P is given to be 90,000. Force is 3600 times displacement, how far it go? Over 60 seconds. Next, question 16. Boundary motion can be observed by the behavior of smoke particles in a smoke cell. What is this evidence for? So this does not show that air is a poor conductor, okay, of heat. It shows that air is moving, and they are actually moving constantly and randomly. Okay, air molecules does not have more mass than smoke particles. Convection occurs in air. No, it doesn't show the expansion of air becoming less dense and more dense. Question 17. A partially inflated balloon is placed inside a bell jar. The bell jar is connected to an air pump. The pump is switched on and the air is pumped into the bell jar. The pressure in the bell jar is increased. P increases. What happens to the pressure and to the volume of the gas inside the balloon? So imagine you should initially maybe have 3 gas particles. Now you put in more. Now there's 6. You have a certain velocity. Okay, what will this do is that since the volume is constant, you can actually look at the equation PV equals to nRT for the jar. The volume of the jar stays constant because it's a glass jar. It cannot expand in size. The temperature stays constant. This is the ideal gas constant. We increase the number of molecules, definitely the pressure increases. So you can see that why the pressure increases. And because this pressure increases, there is an additional force by the additional particle exerted on the balloon. And this force will actually decrease the volume of the balloon and increase the pressure of the balloon. Okay, next. Question 18. The temperature of a gas is increased. Which property must increase? So as we know, temperature is proportional. The speed is actually proportional to the temperature, which affects the kinetic energy of the particle. So if temperature increase, speed increase, Ke increase, and internal energy is equals to IKE plus IPE. Question 19. A block of copper is at room temperature. Which row describes the block, a smaller block of copper at the same temperature? So smaller block. Okay. Internal energy is actually proportional to the mass. A larger object will have more internal energy. Okay, so a smaller object will have less heat capacity. We know the formula C, big C equals to MC. So it is dependent on mass. So it should be less. Whereas specific heat capacity C is independent on mass. So it should remain the same, but it's dependent on material. Okay, question 20. A room is heated using an electric oven at floor level. Which statement about convection in air is correct? A says heated air becomes less dense and sinks. Wrong. Heated air or hot air expands. Okay, you add this, becomes less dense and rises. Cold air, which is more dense, sinks. So this sets up a convection current. Question 21, not tested. Question 22. Equal masses of oil and water are heated to 90 degrees and allow it to cool. Which statement explains why oil cools faster than water? Oil has a higher boiling point than water? Nope. Lower boiling point than water? Nope. Lower latent heat? Nope, because it's only a change in temperature. There's no change in state. Okay, it's just being heated up. Okay, it's not being boiled. So oil has a lower heat capacity than water, because heat capacity C is actually the change of its internal energy per unit mass for each unit change in temperature. Q over M change in theta. Question 23. A boat oscillates vertically as the water wave passes. The graph shows the displacement of the boat from its equilibrium position varying with time. So when you have a displacement time graph, you will find period T. So one full oscillation, you get period. Here you get the amplitude. So this frequency equals to 1 over T. You can calculate it. Question 24. A metal plate is oscillating up and down continuously in 4.0 milliseconds. So it goes up and down. It moves from the bottom to the top. So bottom to the top is only half a oscillation. So it means half a period is equals to 4.0 millisecond. If it goes from the bottom to the top and back to the bottom, then it's one full oscillation. That's one period. The oscillation of the plate causes the sound wave to be generated in the sounding air. Sounds travel at a speed of 340 meter per second V. Now they ask, what is the wavelength? So the formula, since we got period, F equals to 1 over T, you can find frequency. You can submit the formula, V equals to F lambda. Question 25. A ray of light is incident on a horizontal plate as shown. The light is reflected straight back. Now the mirror is tilted through an angle of 10 degrees. What is the angle between the incident and the reflective ray? So they're asking you I plus R equals question mark. So now it tilts at the angle 10 degrees. Draw the normal. By the law of reflection, it should be 10 degrees as well. I should be equals to R. So I plus R is equals to 10 plus 10, 20 degrees. Question 26. Light travels from one medium towards a less dense medium. Is refracted along the boundary between the mirror as shown. What is the critical angle? So for total internal reflection, your I must be greater than your C. They'll be totally internal reflected. Okay, so if it travels like this and runs along the boundary, you can use the angle of incident to find the critical angle. So in this case, your I is equal to your C, small c, critical angle. Question 27. An object is placed in front of a thin converging lens at position X. The distance between the center of the lens and the focal point F is as shown. The object is then moved towards the lens from position X to Y. Okay, so which row describes the image formed with the object placed at X and Y? So if you don't want to draw the ray diagrams, if you know that for object at X, okay, the distance from the lens is between F and 2F. Okay. So 2F is roughly here. Okay, so here is roughly 2F. Since the object is between F and 2F, okay, you know that the image will be inverted, magnified, and also real. For object at Y, is now image is less than F, less than the focal point F. So you know that the image is upright, it's going to be magnified, and it's going to be virtual. Okay, now I'll draw and show you how it look like. For object at X, you draw the first line through the optical center. Second, touches the center of the lens, and it should bend down. Okay, you need to find the focal length first, focal point here. Okay, then it should we see the image. I. It's inverted, it's magnified, and it's real. I'll put the arrows. Okay, now if the object is moved to Y, okay, same thing, you have the first line here. Then you will have the second line that touches the converging lens, like this. You realize that it doesn't converge. Okay, so you need to draw the other lines. This one have to be dotted. Dotted. And then the image. Dotted. So here you can see that the image is upright, magnified, and virtual. Next, question 28. A glass prism have an angle of 45 degrees, 90 degrees, and 45 degrees. Okay, the critical angle for the glass C is 42 degrees. Which arrangement shows that the beam undergoes total internal reflection twice before any light leaves the prism? So here you can use your projector. You can draw here. Goes in here. Draw the normal. Here, 45 degrees. And because 45 degrees is the angle incident is greater than critical angle, TIR occurs. So next, it hits here also. Angle incident, 45 degrees as well. I is greater than C, TIR. And this is how it should look like. Okay, question 29. A teacher has two identical plastic pens. They are both rubbed with identical cloth. Rub. So it means charging by friction. The first pen is balanced on an insulating support as shown. The pen rotates when the cloth or the second pen are held near it. So which statement is correct? Okay, so first we know it's charging by friction. And then since they are used the same identical cloth to charge, okay, both pens must be similarly charged. Okay. The third fact is that the pen and the cloth, since they are actually ripping electrons off, one of it must be differently charged. So the pen and the cloth are oppositely charged. So cloth should attract pen, pen should repel pen. Okay, question 30. A negatively charged copper sphere rests on an insulating mat. So they will highlight the word negatively charged. Initially there is 3 charges. A negatively charged polyethylene rod is brought near the copper sphere, which of the diagram shows the charge distribution. So negatively charged rod, okay, should repel the electrons to the other side of the sphere. And because initially it has 3 additional charge, so in total it should have 3 to counteract from the positive charges and from the previous 3. So it actually should have 6 charges. Next, question 31. What statement about electric current is correct? Electric current I. As we know the SI unit, if I ask you for SI unit, you must give me the word ampere. And then the symbol A. So it is the flow rate of flow of charge and the unit is ampere. I is equals to the formula charge over time, rate of flow. Okay, the charge unit is coulomb, C. Okay, not rate of flow of electrons. Okay, rate of flow of charge. So in this case, also wrong. Okay, question 32. The diagram shows how the current in a semiconductor diode varies with the potential difference as it increases from 0. So you have the graph current I, PD, which is a V. So it's the IV curve. What is the resistance of the diode between P and Q? And how does it change as the PD increases from Q? So between P and Q, the gradient here, okay, is 0. So we have the formula, Ohm's law. R equals to V over I. I rewrite the equation, I equals to V over R. Okay, we see that for a IV graph, the gradient is equals to 1 over R. So for a gradient to be 0, the R must be insanely huge or infinity. So when R goes to infinity, then your gradient your gradient 1 over R goes to 0. Okay, so for the first part, resistance between P and Q is infinity. Then what's the resistance after Q? Okay, as we know, the gradient is 1 over R. So we can actually look at the gradient. So what's happening is that the gradient is increasing. So for increasing gradient, R is inversely proportional to the gradient. So R is decreasing. This gradient equals to 1 over R. So R is inversely proportional to the gradient. Decreases. Okay, question 33. The voltage current readings, the VI readings, were obtained for different electrical components. What are the readings for a 3 volt 0.6 amp torch lamp? So as we know, a torch lamp is a non-ohmic conductor. So for a non-ohmic conductor, as the temperature increases, resistance increases. So let's calculate VI using a formula R equals to V over I, Ohm's law, resistance slash ohms. Okay, 0 divided by 0, 0. 1 volt divided by 0.025, because this is milliampere and you convert to ampere, you get 40. 2 divided by 45 milliampere, you get 44 ohms. 3 divided by 60 milliampere, you get 50. You realize that this trend shows that the resistance is increasing. So, B. Question 34. The diagram shows an old vacuum cleaner with a metal case and plastic wheels. The plug of the vacuum cleaner is incorrectly wired as shown. What is the effect of this, of using the plug wired this way? So you can see that what's wrong is now the earth and the live is connected, okay, to the fuse. So the current will enter the fuse, okay, and go into the live wire. No, sorry, not live wire, but the earth wire. So the earth wire is actually connected to the metal casing. And this caused the metal casing to become live. Next, question 35. The student sets up the circuit as shown. Yes, EMF 12 volts. Okay, you have a ammeter. Okay, here. So we measure I1. There's an ammeter here. Measure I2. Okay, so we know that I1 and I2 follows the same path. So actually I1 should be equals to I2 equals to 4.0 ampere. Okay, next, V2 and V3 are in series. So we know that the EMF should be equals to V2 plus V3. EMF was given as 12 volts. We're trying to find V2. V3 is given as 4.0 volts. So V2 equals to 8.0 volt. Done. Question 36. The diagram shows a magnetic field surrounding a wire PQ. So current, conventional current, flows from positive to negative, this way in, using the right hand grip rule. Hand grip rule. You should turn. You realize that it's this direction. So it is clockwise direction. As we increase the current, the magnetic field strength should increase. As we decrease the current, the magnetic field strength should decrease. So when current decreases, magnetic field strength should decrease. And how does it look like in terms of drawing the magnetic field? It should go further apart. The concentric circles should be further apart this time. Question 37. The diagram shows the north pole of a magnet going in and out of a coil of wire. This motion creates a current in the coil of wire. Okay, so why does this happen? Due to Faraday's law as well as Lenz's law. Okay, this current produces a magnetic pole at X. What pole is produced at X when the magnet is moved in and when it's moved out? We mentioned before, Mother Nature wants to remain status quo. So if the motion is towards the right, it will form a north pole to resist the magnet. But if the magnet is going out, it should have a south pole to attract back the magnet. 38 is not tested. Question 39. What material is used for the core of a transformer and what's the reason? Okay, so first what we want is a soft magnetic material like iron, okay, to concentrate the magnetic field. So not copper. And copper is also a non-magnetic material. Okay, in the transformer, the current doesn't flow in the core, only the magnetic field. Okay, so out. And what we want is a soft magnetic material so it can easily magnetize and demagnetize. Question 40. The electric power cables transmit electrical energy over large distances using high voltage alternating current. What's the advantage of using high voltage and of using alternating current? High voltage means you result in low current, and that reduces energy loss. Okay, which is, you know, formula P equals to I square R. Okay, if we can use lower current, we reduce the power loss. And the advantage of using alternating current is that the voltage, okay, can be changed using a transformer. You can either step up the voltage or step down the voltage using a transformer. And that's the end of this paper.